For our first problem on related rates, we have a particle that moves along the graph of the equation y equals x squared minus 9 in such a way that its x-coordinate is moving at a rate of 3 units per second. And we want to find the rate of change of the y-coordinate when x is negative 7. So first thing we need to figure out is what we're given, what we're being asked to find, and the equation we're going to use that relates those quantities. So the good news about this problem is we were given the equation, so we can start there. So which equation were we given? Y equals x squared minus 9? Okay, so we know immediately that our two variables are just x and y. And what's happening on that parabola is there's a particle, and it's moving along the graph at a certain rate. And we don't know a whole lot about the rates, but we can sort of start to piece it together. So let's look at some of the given information. It says that the x-coordinate is moving at a rate of 3 units per second. And we have to figure out a name to give that. So what we're going to do is, instead of using like y prime like we have in the past, because y prime is always dy dx, these have to be with respect to time because they're rates. It's not quite the same as finding slope of the graph. It's a particle that's actually moving along that path. And so when we write that down to track like what we're going to call this 3, we're going to write it as d, whatever the variable is, dt. So it's going to look weird, it's going to have some fractions. So we will say that dx dt, and that stands for the rate of change of x with respect to time. It's sort of like having an x prime with respect to time. But there are so many variables here that if we don't track it with a different name, you're going to get confused. So every time you write down a rate, you're going to do d, whatever the variable is, dt. And that is positive 3 units per second. So we'll just say, look at it like that. What are we asked to find?
X is negative 7.
The rate of change of the y-coordinate when the x value is negative 7 units. Okay, so we're being asked to find the rate of change of the y-coordinate, and we will name that dy dt. Every rate will be d something dt, and you just use the variable that's given there. That's what we're being asked to find when x is negative 7. Okay, so once you know what you're given, what you're being asked to find, and the equation that is used to connect those two variables or relate those two variables, what you do is you go to the equation and you take the derivative implicitly, but with respect to time, not with respect to x. So you simply say, what's the derivative of y?
Y prime.
1. Normally we would say y prime, but we're not with respect to x. Y prime only works when we're with respect to x. So you have to say the derivative is 1 dy dt. Okay? What's the derivative of x squared?
2x.
Normally we don't need anything after the 2x because we're going with respect to x, but we're not now, we're with respect to time. So we say the derivative of x squared is 2x times dx dt. So every time you take the derivative of a variable, it will have a d something dt with it when you're working a related rates problem. So it's going to look really busy. What's the derivative of negative 9? 0. So this is all we need. That's our derivative, and we should be able to find what we need from there. Which one am I finding?
dy
dy dt. So this is going to be my unknown. This is what I'm solving for. Everything else I should have enough information to plug in for. So I know that dy dt equals 2 times, which x am I supposed to use? Negative 7 times dx dt,
3.
which is 3 what? 3 units per second. And we multiply all of those together, and we get what?
Negative 42.
Negative 42 units per second. So when x is negative 7, the y-coordinate is moving at a rate of negative 42 units per second. For our next example problem, we have a spherical snowball, and it is melting such that its volume is decreasing at a rate of 0.5 cubic centimeters per minute. When the diameter is 8 centimeters, at what rate is the radius decreasing? So this is a whole different type of problem. First off, you weren't given an equation, but it's a geometric situation, so we should be able to figure it out. So we have a snowball. Is that 2 or 3 dimensions?
3
Three.
dimensions.
That's why we're dealing with volume here, as opposed to, with 3 dimensions, you can deal with either volume or surface area. With 2 dimensions, you're usually dealing with area, perimeter, things like that. Okay, so we have a spherical snowball, and it's melting such that its volume is decreasing at a rate of 0.5 cubic centimeters per minute. That's what we're given so far. So what we're gonna do, we're gonna start writing things down and assigning variables to them. For me, it's easiest to find the equation in these first. I need a volume equation, volume because it mentions volume, right?
Mhm.
And it also mentions the radius and the diameter, okay? So I need a geometric formula that relates volume of a sphere to a radius or a diameter, either one. So we're gonna pause and we're gonna let you guys see if you can find an equation that does that.
So would that be?
So we found a formula for volume of a sphere, and we know that the volume of a sphere equals 4/3 pi times the radius cubed, and that's gonna always be true. So with that situation, it looks like my 2 variables are gonna be the volume and the radius. Is that okay?
Mhm.
Okay, so when we deal with the rates here, we're gonna be dealing with dv dt and dr dt. So we're gonna look back at what we were given. We said that it's decreasing, which means it's a negative rate,
Mhm.
of 0.5 cubic centimeters per minute, and that's my volume. I can tell, first off, it explicitly says so, but also because the units are cubed. So I am given that the change in volume, so the rate of change of the volume, is equal to 0.5 cubic centimeters per minute, but it's negative because it's decreasing. And it is going to be important that you pay attention and put the negatives on where they go. What are we being asked to find? We are being asked to find dr dt because it says at what rate, that tells me it's a d something dt, is the radius decreasing. So we are looking for dr dt when what? When the diameter is 8 centimeters. But since we have radius in our problem, can we go ahead and convert that to the radius? So if the diameter is 8, what will the radius be? 4. Okay. Once we kind of have all of that laid out, we just go to our equation and we take the derivative with respect to time. So the derivative of capital V is going to be 1, but you have to put with it dv dt. Every time you take the derivative of a variable, you have to put the d whatever dt. So this would be 1 dv dt. And then it may be a little hard for you to see this, but this whole thing is the coefficient. So if I want to take the derivative of the right side here, I'm going to just do the power rule and say 3 times the coefficient, so 3 times 4/3 pi,
So it's just 4 pi.
so just 4 pi.
Okay.
Down 1 on the power, but you can't forget to put on your dr dt. And all of that stuff is just multiplied together. The differentiation is usually pretty simple in these problems. Once you have the derivative there, you simply plug in what you know and solve for what you're hoping to find. So, I'm hoping to find dr dt. So I need to substitute some number in for each of the other quantities. I know dv dt is negative 0.5 cubic centimeters per minute. I have 4, I have pi. My radius is 4 centimeters, and then we're going to square it, and then that's going to multiply by the rate of change of my radius. So let's clean that up as much as we can. We have negative 0.5 cubic centimeters per minute equals 16 pi square centimeters multiplied by the rate of change of my radius. So I'm going to pause for a second and see if you have any questions. So apparently I made a mistake here, and that should be what?
64.
64, yeah, because we have a 4 here times this 4 squared is 16 times 4 is 64 pi square centimeters. Thank you. Okay, are we okay so far? All I have to do is rearrange this so that dr dt is by itself. So I just need to divide both sides by what?
64 pi.
64 pi square centimeters. So we're going to divide both sides by 64 pi square centimeters. And that is going to be what our final answer is. And if you track your units, they should work out and when they should make sense to you. If I take negative 0.5 and divide it by 64, could someone get a fraction of that for me? Negative 0.5 divided by 64? I think it's like negative 1 over 128.
Negative, yeah.
Is it? Okay. So it looks to me like dr dt equals negative 1 over 128, but the pi's down there too, right?
Yes, ma'am.
Yes? Okay. So we divided these two numbers, and the pi is on the bottom. And look at this cubic centimeter over a square centimeter. That's going to leave me with just a linear centimeter, right? Centimeters per minute. So a lot of times in calculus, they'll leave the answers exact like that. So like that's certainly an acceptable answer. But you could also actually type that in and round it. So
What would you want us to round to?
I will usually tell you, but for right now, let's just do 3 decimal places. Does anybody have an answer yet? Negative what?
Negative 0.008.
Negative 0.008. Does everybody get that? Okay. Negative 0.008 centimeters per minute. So let's see if that makes sense. I had a snowball, right? And it was melting. So its volume was shrinking. And its radius, would it be shrinking or getting bigger? Shrinking. So that's why it should have a negative rate of change as well. So when we typed in the negative 1 over 128 pi, did you guys put the pi in or not? You have to. Like if you're going to turn it to a decimal, you go all the way to a decimal, like the whole thing. So it's going to help if you use alpha y equals, and if you do that, what do we get? Negative 0.0024. Okay, so negative 0.00, so we'll just say 2 centimeters per second. No, centimeters per minute. All right, is everybody okay with that? Make sure that when you type them in, you're getting the right answers, because it's certainly not going to do any good to go to a decimal if we don't go to the right decimal.